With Unit 3.10, we're going to continue writing and solving rational equations and inequalities. And we're going to do this for the next couple of days. So want us to really make sure we have a good toolbox full of things that we can use to help us create equations. So before we get started, let's take a look at some of those. The first thing that is really helpful in writing equations is understanding what it is we're trying to find. So that includes not just saying, okay, hey, I'm trying to find the speed someone was walking, but saying I'm going to give that a variable name. Maybe it's s, maybe it's x, maybe it's y. And that will just kind of get us on the right foot because we'll know that our equation must include that variable, right? I can't solve for the value of a variable if it's not in the equation. The next thing is to try simple cases. So if I try some simple cases, maybe I'm only adding 1 liter, or maybe I'm only going 1 mile per hour. I can start to then understand what the general rule is. So maybe I try the case at the beginning, maybe I try when there's only 1, only 2. We saw that with the liters of water and the concentration. I can then make it a general rule eventually. The last thing, and I think this might be the most helpful of the three, is writing out the equation. So sometimes it's easier to just say the relationship than to actually represent it with variables. What I mean by that is, let's assume we're taking a trip, and I know that the time it took to get there plus the time it took to get back, that's got to equal the total time. And now from here, I can start to think about, how do I represent the time on the way there, the time on the way back, the total time? And that can get us started and be a really powerful tool for putting together the total equation. All right, so a high school decides to spend $750 on student achievement academic awards. We know that 5 awards have already been assigned. All awards are of equal value. The question is, how many more awards should be given out if you want each award to be worth $95 or less? So pause the video, go through, annotate, mark it up, come up with a plan, and go ahead and try to find the answer on your own. Make sure that you either split your paper in half horizontally or vertically, and label your first try, and then we'll go ahead and talk a little bit about it. So there's a lot of information here that they kind of just heap on you, a lot of stipulations. But the basic thing that we walk away from is that we're trying to discover how many more awards should be given out. So we'll use, let's say we use X to denote the additional number of awards that we're going to give out. And we know that we have to make each award $95 or less. So there's a couple of different ways we can do this, but the first thing you're probably thinking is, I need to write some sort of equation which will include X and will be able to tell me the worth of each award. So to start out, let's just write out how we would calculate the worth of each award. So the worth of each award, pause the video and try this on your own. The worth of each award is just going to be the total amount of money, and I should just write total amount. The total amount of money divided by the number of awards. And so now that I have this written out, I can sort of start plugging in things that I know. So let's just call the worth of each award W. The total amount of money is $750. And the number of awards is going to be the 5 we've already given out plus the X that we're adding on additionally. So it'll be 5 plus the X number of awards that we're adding on. So now at this point we have an equation that we can use. We know that all of the awards should be 95 or less. And so here we have an opportunity. We can do one of two things. We can set W equal Now if I set W to 95, the amount of each award, and I solve, I will have to do a little bit of interpretation. Why do I say that? Because we don't want the worth of each award to be exactly $95, right? We want it to be $95 or less. In other words, we want this price here to either be $95 or we want this price to be less than $95. So instead of using an equal sign, we can actually use an inequality here. We can say that we want this value to be either less than or equal to $95. So now when I solve, I have this less than or equal sign here, which will allow me to better interpret my x value. So I'm going to pause the video now, and you're going to go ahead and solve this on your own, interpret your answer, and we'll talk in just a few seconds. So when I start solving, I'm going to multiply, just like I always have. I'm going to get my variable out of the denominator by multiplying by 5 plus x on both sides. So I have my less than or equal sign, and on the left side I'm going to divide through or multiply through. Now I have 475 plus 95x, and on the right side 5 plus x over 5 plus x is 1, so I'm all good to go there, and I just have 750. Okay? And if I think about this, this makes sense, right? I'm taking the total number of awards, multiplying it by 95, and that's got to be greater than this total 750. That will allow for each award to be less than the $95. Okay? So let's go ahead and solve for x now, and that will give me 95x less than or equal to 750 minus 475 is 275. And now I divide by 95 on both sides, and I'm going to get that x must be greater than or equal to 2.89. So here we have to interpret our answer, right? Notice that if we had left this as an equal sign, we would have said that x would be equal to 2.89, meaning the more awards we added on, the number of awards we added on should be 2.89. But you can't add on 0.89 of an award. So we would have had to decide, do I need to make this greater than or less than 2.89? Do we want it to be 2 or do we want it to be 3? And by incorporating the greater than or equal sign from the very beginning, we get our answer at the end. X needs to be greater than or equal to 2.89, meaning that the smallest value x could be would be 3, because I can only add a whole award. So I need to at least add 3 awards. That will ensure that each award is less than $95. So the key here is to realize, look, we're writing an equation, that's great, but in our solution, what we're looking for is something that's either 95, either equal to 95, or less. And so what we want to do is we want to be as specific as possible and include the less than, so that when we get our answer, it's much easier for us to interpret. Okay, so when I write this out, I would say that we should add at least 3 awards. Okay. All right, one more problem for us to take a look at. So here's the question. I'll let you read through it. You graduated college, and this should say and, just got your first car here. And, just got your first car. You plan to drive a certain number of miles. Your car gets 24 miles per gallon. Gas costs $3.60. And here's a bunch of questions. First one's pretty straightforward. In B, C, and D, we want to actually start writing some equations here. So part A is very simple, very straightforward. Get a handle. It's a very simple situation for you to look at. And that will allow you to start thinking about B, C, and D more clearly. Okay, so make sure you try this on your own. Have some questions, some places where you weren't sure what to do, try a couple different things so that tomorrow we can come in and really have a productive conversation, and you can bring something to the table. Remember, you do not want to be the person that shows up to the team meeting with nothing to offer. That's how you're getting fired. Good luck, and we'll see you tomorrow.